Hello and welcome to this video. In this video we'll look into the project structure, the file structure of KMP, Kotlin Multiplatform Project. My name is Per-Erik and don't forget to like and subscribe. The first thing we have the Compose app. This is the core of a KMP project. We also have an iOS app folder. This is a pure Xcode project. You will recognize it if you look into it. If you made a decision to not share the UI, this is where you have to put your Swift UI code. You can run this in Xcode, you implement your UI there. You can access the Compose application just by adding an import to Compose app, and then you can access the APIs or the function and classes, etc. that you implemented in Compose app. You would expect to see an Android app as well, especially if you created a project with Android Studio. Let me just quickly switch to an Android Studio project so you can see. Here we have an Android Studio project. We can see here that we have the Android application, we have the iOS application, and we also have a shared application. If we look at the Android app, we can see that this is an Android application, while the shared is an Android library. So what they did is they merged the Android app into the shared. They also added Compose support for Compose Multiplatform directly and renamed this one to Compose app. So, for example, if we now go into this Compose app in the JetBrains structure, we can see that this is an Android application, not a library as it was in the Android Studio. There are some benefits of this is because when you're trying to configure your application, like you need to programmatically change the name, you might want to change the application ID or so on. It's much easier if you can do it from this shared code. So let's look into this Compose app a little bit. We have the source folder, and of course this is where all the source code goes. But inside this one, we have 1, 2, 3, 4 different folders. First of all, we have a common main. This is where we put all our shared code. Then we have additional folders for each target that we have. In this case, I have the Android, I have a desktop, and I have an iOS as targets for this one. In the common main, I have an app file. This is the app function. This is kind of like the entry point to our Compose application. Looking at this one, this is just a traditional way how to do Compose applications. Just the same as any Android developer will do. Compose Multiplatform have the same APIs as Jetpack Compose. So if you need to learn it, you can go and look for Jetpack Compose tutorials. If you look into the Android main here, we can see that it's a traditional Android project. We have the Android manifest, we have the resources, and we have the activity, the main activity here. Here we are actually calling this app function. So this is the entry point into the app, and we are just calling it from here. If I go into the desktop main, we have a similar situation. We set up the window and then we call the app. And of course on iOS we have the same. We have the main view controller that returns the Compose UI view controller, and that will call this app function. So we mentioned already that we want to put as much as we can of our code into this common main. And there are a couple of ways to achieve this. The first and easiest one is, of course, to not use any third-party libraries. We just write pure Kotlin code. But of course, that's not always possible. If we need libraries, the first thing we need to look for is libraries that are KMP compatible. Because if they are KMP compatible, that means that we can use them inside this common main directly without adding anything to the Android main, desktop main, or iOS main. The second approach would be, let's say that you have some need for platform-specific APIs. For example, you might want to access text-to-speech engine for Android and iOS or desktop. Then you need to use something called expect actual. What it means is that we add expect in front of, for example, a function here, and then we telling KMP that it can expect these to have an actual implementation in the different targets. This can be done on classes, properties, etc., etc. If I go into Android main to the platform, I can see that here we actually have the implementation for this one. And of course, we have the actual implementation in the other target folders as well. KMP project is wrapped in a Gradle build system. And I will show a little bit what it is and how it's built up, but I won't go into too much detail. I have the plugins block at the top where I add plugins for the build system. I then have a Kotlin block. This is where I have the target and the source sets. When it comes to target, I have the Android target, I have the desktop target or a GVM, and then I have the iOS targets. We also have the source sets here, and this is where we add dependencies. We have the Android dependencies, we have the common main and desktop main. The goal we mentioned is to use as much KMP compatible dependencies as possible, and those goes into the common main. If I have Android specific dependencies, I put them in the Android main dependencies, and for desktop I add them to the desktop main dependency. For iOS, it's a little bit trickier. We need to add a plugin at the top for handling Cocoa Pods. We also need to define a Cocoa Pod block inside this Kotlin. Since this Compose application is the entry point for both Android and the desktop, we also need to be able to configure those. And that you do in this Gradle file as well. For example, you have the Android configuration where you have basically the same things as you have in a traditional Android project. And then, of course, we also have the composed desktop. When it comes to configuration of the iOS, it is all inside Xcode in the iOS project. That's it for this video. It was a short one, just going over the project structure a little bit. In the next one, we will go a little bit more hands-on. We will implement a small application and see how that goes. Please like, share, and subscribe so you don't miss it.